Welcome, everybody. We're going to continue our discussion in state trees, and today we're going to talk about evaluators. All right, let's demystify this thing called evaluator. When I'm building an AI using Unreal State Tree, I picture the whole system like a newsroom. The tasks are the reporters, they go out and do stuff. The transitions are the editors deciding what story runs next. And the evaluators, they're the researchers working in the background, pulling the facts so everyone else can make smart choices. Concretely, an evaluator is like a lightweight C++ or a blueprint class that runs on schedule, usually every tick or at a custom interval. Its sole job is to observe the world, crunch a quick piece of logic, and stash the result in the state tree context. Think of it as the AI's heartbeat monitor. Is the player within 10 meters? Is my stamina below 20%? Did a enemy just enter into my line of sight? Every frame it updates those vitals. So when the transition checks a condition, every frame it updates those vitals. So when a transition checks a condition, the answer is already waiting. No expensive queries, no tangled blueprint spaghetti. Because evaluators never execute actions, they're dirt cheap and thread safe. They just collect data, keep it current, and hand it off to the decision makers. Strip away the fancy name, and an evaluator is simply real time situational awareness packaged in a reusable class. And that, my friends, is why your AI feels smart before it even lifts a finger. I've created 3 evaluators for our sample so far. First evaluator is the AI perception evaluator. So it monitors the context actors' AI perceptions. Those perceptions we saw in the previous video, the sight, the hearing, the damage, it monitors those for any of those vents that fire, so then it lets the state tree know. Distance to player evaluator. So it calculates the distance between the state tree's context actor and the player. And then we have a health evaluator. And this perception monitors the context actor's health. We may want to monitor health because we may want them to change tactics when their health is low. Like we may want them to flee. We may want them to become a more defensive player, or any number of things we can do when the player's health is low. Something like stamina, as we said before, could be evaluated in the same way and that kind of thing. So let's jump over to the code. So our perception evaluator, as we just talked about, it's monitoring the AI perception of the context actor. It's utilizing the tree start and the tree stop. These functions are basically when the evaluator starts and when the evaluator stops. As evaluators, they're running the life of the state tree. So I'm assuming that's why they call it tree start and tree stop and not evaluator start or stop, because they are starting when the tree starts and they stop when the state tree stops. And then you'll see this often, the description, and that's what you see here: monitor context actors AI perceptions. And so that gives that description here on the bar. Descriptions are going to become very important when we get into tasks and conditions, as you'll see those in plain text within the tree. And I'll show you how to read bind properties and things like that to print out exactly what that task or that condition is going to do in plain text. There's also get icon and get icon color, which these work much better when you're using the struct version. And evaluators, the evaluators that I've written so far, I'm using the blueprint base class for the evaluators, but all my task and conditions and things are using the UStruct, which these seem to work better on the UStruct. This is how we bind our context properties into our evaluators. So when you saw the context here, that's equivalent to the context actor and AI controller. On evaluators, actor is a taken property, so I couldn't call actor on the evaluator, I had to change it to character. It's binding to the actor and the AI controller. So technically we can call it whatever we like because the binding is here. And if you don't see that, you can just select the little drop down here and choose actor if it's some other value. And the magic sauce there is the category equals context. So when you do that, it automatically sets it up as the context. Here's our acquired target, which is an out parameter. By setting the category to out parameter or output, it's telling the state tree in Unreal that this is exposed out. And you'll see here, it says out, acquired target, it's of actor class. So these are just functions needed for this evaluator that are monitoring those events from the AI controller. And here's a property if we need access to the state tree that this evaluator is running on. That's what that property is for. The distance is similar. We're using the same base. This one has a tick. The perception evaluator is waiting for event to happen. The distance and the health are using a tick to actively gather that information every tick so that it's available. And so that's why these two have a tick. And everything else is pretty much the same. The implementation is a little different, of course, because the code's in the tick. And if you want to see that code, just go up to the GitHub. We are doing the same context, and the output is a float of distance for this one. And then quickly, the health is the same thing using the tick, and we're sending out a float, which is the current health. Lastly, what we're going to do is we're going to set up a little more of our state tree for the next video. We're going to add 3 states, and these are going to be our top level states. This one idle, this is going to be patrol, and we'll give the color to the patrol, and this one's going to be combat. We'll give it to the combat color. In our next installment, we are going to talk about these top level states, exactly what the state is doing, all this information here on the right so we can understand it. And we're going to learn how to assign events to these, and we will be able to enter any one of these states by just sending the state tree the event. So it allows us to pinpoint and control exactly what state we go into based on sending that event. I hope that you guys learned something on this one so far. I hope you're liking the series so far. Please like and subscribe. Thanks, guys.